Un saludo para la raza de Caborca que anda por la Quirós. ¡Que le caiga para el río!
Vamos a bailar, vamos a gozar.
Hi, my name is Benny.
I'm Gonzalo,
I'm Lewis.
and this is our chemistry video.
And today we're going to talk about the properties of gases and the kinetic molecular theory. Today some of the words you should know are volume, pressure, temperature, and STP. First of all, volume, the amount of three-dimensional space occupied by a substance, and temperature, and pressure, constant random collision between tiny particles and the walls of the container. Temperature, measure of the random motion of the components of a substance, and STP. STP stands for standard temperature and pressure. It is at 1 atm at 273 Kelvin or at 0 degrees Celsius. And for Boyle's law, we move on. Boyle's law is the pressure of a gas. The pressure of a gas is inversely related to the volume of the gas in constant temperature, and the equation is P1 times V1 equals P2 times V2. Here's an example. As you see, 1 atm times 22.4 milliliter equals 2 atm times V2, volume 2. In order to solve this, we'll have to divide 2 atm on both sides. And then cross this, and you'll get 22.4 milliliter over 2 atm equals 11.2 milliliter. And since the pressure on one side is 1 atm and 22.4 milliliter, on the other side it is 2 atm, causing the volume to decrease by 0.5, making it 11.2 milliliter. And
All right.
That's how you get that.
Good job, Benny. Good job. Let's give a round of applause. Alright, so Benny explained for us Boyle's law, but he didn't explain the other two laws, which are Charles' law and PT law. First of all, Charles' law has to do with the volume of a gas which is directly related to the temperature of the gas at constant pressure. Here we have the equation. V1 over T1 equals V2 over T2. And let's just pretty much do the example now. Okay, first of all, V1 is 22.4 liters, T1 is 273 kelvins, and 44.8 liters is V2, and T2 is the variable that we're going to solve for. Alright, in order to get T2 by itself, so we could solve for T2, we got to multiply by T2 on both sides. Multiply by T2, multiply by T2, which crosses out on that side. Yeah, crosses out on that side. Then ends up with T2 on this side. Oh god, it's going to be complicated. Then we got to multiply 273 kelvins to take it out of this side too. Then we still have 22.4 liters on this side, and it's multiplying, so we got to divide that. We got to divide 22.4 liters. Looks kind of ugly, but here's what we end up with. 273 kelvins multiplied by 44.8 liters over 22.4 liters. In order to solve for T2, we gotta divide 22.4. No, we gotta divide 44.8 by 22.4. We get 2. So we multiply 273 kelvins by 2, and we get 546 kelvins.
That was a pretty good job, Luke.
Alright, we got a graph here to demonstrate the relationship between volume and temperature. As you can see, as the volume increases, so does the temperature. And has to do the same with helium and hydrogen. Alright, let's move on. Next law, PT law. PT law has to do with the pressure of a gas and the temperature. The pressure of a gas is directly related to the temperature of the gas at a constant volume. Here we have the equation. P1 over T1 equals P2 over T2. And in our example, we have P1 over 273 kelvins equals 2 atms over 546 kelvins. In order to solve for P1, we gotta multiply each side by 273 kelvins, and we end up with 2 ATM multiplied 273 kelvins over 546 kelvins equals P1. In order to calculate P1, we gotta divide 273 kelvins by 546 kelvins. We end up with 1/2 since it's just double 273, and 1/2 times 2 equals 1, and that's P1, 1 ATM. Next, you want to go next? Go.
I guess. Oh,
Thanks, Benny. Almost forgot. Here we have our graph for PT law. As you can see, temperature increases. So does, as temperature increases, so does pressure. Yeah. All right. Next. Next is Gonzalo. You're gonna talk to us about. What are you gonna talk about?
the kinetic molecular theory. Kinetic states that gases consist of tiny particles that are either atoms or molecules. That's the reason why gases have mass. Particles have a very large distance between them compared to their size. They have a large distance, so we can have compressed air and like stuff like that. You can compress them. Particles are in constant random motion and collide with the walls of the container. These collisions cause pressure. Particles are not assumed to attract or repel each other. The average kinetic energy of the gas particle is directly related to the Kelvin temperature of the gas.
Alright, you guys, I think that's it.
Don't we need to explain how you change Kelvins? How you change Celsius to Kelvins, Louis?
Alright,
Over here, I'll explain it.
Alright, cool.
Right here, 0 Celsius. To get it to Kelvins, you must add 273. So this would equal 273, as you can see. And to get 96 Celsius,
97, dude.
97, you do the same thing, add 273, and that'll get you 370 Kelvin.
How does that look like 96, dude?
I'm sorry, dude.
Wow.
Alright.
Alright, I think that's it.
Let's see, guys.
Alright.
See ya.